what are we doing today? So most of the lesson will be about a thing called trig equations, but before we move on, we just need to touch on something called the co-functions or co-ratios. Now, in the previous lesson, we spoke about the reduction formula. So that was this one over here. We also spoke about dealing with angles that were bigger than 360. And we also spoke about how we deal with negative angles and when we're reducing them. But if there's another technique that we need to know how to use called co-functions. And when we do co-functions, we use the vertical axis on the cast diagram. So I'm going to draw a cast diagram quickly. And this axis over here is 180. This one is here is 360 or it's 0. And this could also be minus 180, and this could also be minus 360. Now that is the horizontal axis. What I'm interested in is what is the value of this axis over here in terms of, and I'd love for you someone to put that in the chat or to come online and tell me what is the value of that vertical axis over there? What angle do we get to up here? So Sino, Bonolo, Hearties, Luyanda, that is fantastic. We will call this angle up here 90. And then over here, this one over here is going to be 270. However, if we were going in the negative angle direction, we could also say that this axis over here is minus 90 if I was going in this direction. And if I kept going, I get minus 180. And then at the top here, I could also have minus 270. So give me a thumbs up if you understand what the vertical axis is in the cast diagram. For those who don't know what the cast diagram is, we spoke about it a lot in the last 2 lessons, but we didn't talk about reducing a trig thing using a co-function. Okay. So let's try and reduce. Let me show you how you can reduce these co-functions. So if you look at this statement down here, the sine of 90 minus theta, I want to ask you, what quadrant is that in? So tell me in the chat, what quadrant is 90 minus theta? I'll give you a hint. If you go 90, if you start at 0 and you go 90, and then you go back by minus an amount, you end up here. It's going to be in quadrant 1. And in quadrant 1, all of the trig ratios are positive. So I'm going to say the sine of 90 minus theta is positive. But now, I want to ask you, 90 minus theta, how far away is that from the nearest vertical axis? So if I say to you, here's the angle 90 minus theta, it's over here. So 90 minus theta is this angle. How far away is it from the nearest vertical axis? I think it's just going to be theta away from the nearest vertical axis. So now if I want to reduce this using a co-ratio, what's the co-ratio of sine? It's cosine or cos. And so the sine of 90 minus theta is just plus cos theta. Now that is called reducing off the vertical axis or using a co-ratio. And what's different is that I've changed it from a sine to a cos, which is quite different to what we were doing in the previous lesson. So let's just check this works. Let's pretend that theta is 30. So if theta was 30, then I would get the sine of 90 minus 30 should be the same as the cos of 30. So this is saying that the sine of 60 is the same as the cos of 30. Now I want you to go to your calculators and type in and give me a thumbs up if the sine of 60 is really equal to the cos of 30. So Tando has asked why cos. When we use the vertical axis, we always use the co-ratio of that trig expression. So the co-ratio of sine is cos, because cos actually stands for cosine or complementary sine. And complementary has to do with a 90-degree angle. Okay, let's do the next one. If I say to you, the cos of 90 minus theta, which quadrant is that in? Which quadrant is 90 minus theta going to be? Okay, I see in the chat, Itumaleng and Annie have also said quadrant 1. In quadrant 1, all trig ratios are positive, so I put a plus sign. Now I say to myself, if I want to reduce this to a smaller angle, but I'm using a vertical axis, I change from cos to the co-ratio of cos, which is going to be sine, and I write as the angle, how far away is 90 minus theta from the nearest vertical axis? It's just going to be theta. So the cos of 90 minus theta is the same as plus sine theta. Now, I want everyone to try and reduce the sine of 90 plus theta. And I want you to try and write what you think that reduces to using the process I've used now. And there's 3 steps. There's which quadrant is it in? Is it positive or negative? And then ask yourself, how far is it from the nearest vertical axis? And then ask yourself, what is the co-ratio? See if you can write down the answer for the pink one. I like in the chat, I see is positive and negative cos theta. And we know it's going to be cos theta. The question is it going to be negative or is it going to be positive? Would anybody like to explain how they got their positive or their negative? I'm super curious to know if anybody can explain how they determine if it's positive or negative. Let's go to Tegavatso. Can you hear me?
Afternoon, sir.
Hey.
I got positive cos theta because 90 degrees plus theta is on the second quadrant and sine is positive on the second quadrant.
Oh, so good.
Cos is the co-function of sine. So since sine is positive on the second quadrant, cos is also going to be positive.
You hit it out the park. Well done. It's tricky, but 90 plus theta isn't in quadrant 1, it's in quadrant 2. And sine is positive in that quadrant, so it has to stay positive. Now, we go and we say, look, what is the co-ratio of sine? It's going to be cos. And how far away is it from the nearest vertical axis? Well, it's 90 plus theta, so it's just going to be plus cos theta. Very nicely done. I want you to try and do the blue one now. So can you reduce the blue one? And so to answer Ayanda's question, okay, Ayanda, when we use the vertical axis to reduce our trig expression, we have to change from the trig ratio that we start with to the co-ratio. And that's just a rule that we use when we're using the vertical axis. If we were using the horizontal axis, the type of trig expression would stay the same. But because we're using the vertical, it has to change. And that's a rule that you're going to need to learn. So okay, I like what I'm seeing in the chat. So the cos of 90 plus theta, we ask ourselves, what quadrant is 90 plus theta in? Well, it's in quadrant 2, and cos is negative in quadrant 2. And then we say, what's the co-ratio of cos? It's sine. And then we say, how far away is it from the nearest vertical axis? It's that. And so we get the cos of 90 plus theta is equal to minus sine theta. Now, I want everyone to try and answer these questions here. So I want you to try and write the trig ratios as trig ratios of their co-functions. So do those four for me, 1, 2, 3, and 4. Write these as, reduce them using their co-functions. And then if there's a question you'd like to ask, now is a great time to ask it while all the students get busy on questions 1 to 4. Okay, so make sure, Tando, that looks great, but just remember you must include a number. So when I say the sine of 50, how far is that from the nearest vertical axis? So you write it's plus, and you write that it's cos, but how far away is it from the nearest vertical axis? That's going to help you. Yes. So plus cos 40 is the first one. Who would like to tell me number 2? Who would like to come online and tell me number 2? Who feels like they've got this co-ratio thing? Okay, let's go to Masi. Masi, what do you think?
I think it's the way I did it or the way our teacher explained it to us. So I have, since it's cos 70, I would say cos open bracket 90 minus 20 degrees, because that bracket gives me 70 degrees. Then because it's our co-functions, we need to change it to sine 20.
I would agree with you. It's plus sine 20. Absolutely. Plus sine 20. Well done. Okay. I like what I'm seeing here. Let's try and do number 3 and number 4. So you absolutely can do that. So you can say, what Masi was saying now, she was saying, look, you can rewrite the sine of 100 as 90 plus 10. Nothing wrong with that at all. And what that shows you is that the important number that we're really after is this 10. If you like and you can see that, you can also leave that step out, but I would leave it in if you're anywhere unsure. So what's my answer for 3 going to be? I think 3 is in quadrant number 2, and sine is positive in quadrant number 2. So this should be positive. Then the co-ratio of sine is cos, and it should be plus cos 10 for number 3. So looks like that is making sense. Let's give a bit more time for number 4, because number 4 is a bit trickier. So we have to use the co-functions because of the way the question is asked. And so for number 4, what I could do is I could write it as 90 plus 50, or I could just recognize that it's 50 degrees away from the nearest vertical. And in that quadrant, cos, that's quadrant 2. So if I go to my 90 plus 50, it's going to go all the way to there and then another 50. So cos is negative in that quadrant. Then I'm going to write sine, and then I'm going to write 50. All right. So there's been a request to re-explain number 2. So number 2 is the cos of 70, and the cos of 70 is in quadrant number 1. Okay. And so in quadrant number 1, everything is positive. So this would be positive. Then because we're saying how far away is 70 from 90, or you can write it. If you want to see it visually, you can see that 70 is the same as 90 minus 20. So it's 20 degrees away. So then you say, okay, it's positive. And because you're saying how far away is it from the nearest vertical, instead of writing cos, you write sine, and you write the sine of 20. Now, a very good question has been asked by Sino, who said, so could we not also have reduced this angle by using the horizontal axis? And Sino, I completely agree. Now, if you were going to use the horizontal axis, then you would say something like this. You would say, look, 180 minus 40, I can rewrite cos like that. But the question said, in this case, that you must use the co-functions. So that's why we are using the co-function of cos, which is sine. However, if you were given a choice, you could reduce the cos of 140 using the horizontal, in which case this would be in quadrant number 2. So it would be negative cos 40. Now, if you are confused about that, that's because I'm using a different formula. This is the formula for reducing off the horizontal, which we did in the last 2 lessons. When we use the horizontal axis, the trig ratio that's involved stays the same. But if I'm telling you the truth, minus sine 50 should have the same value as minus cos 40. Otherwise, something's gone wrong. So I want everyone to type minus sine 50 in their calculator, and then type minus cos 40 and ask, do they give you the same value? If they do, give me a thumbs up. So what I'm saying is, I've shown you 2 different ways to reduce the cos of 140. The one way is to use the vertical axis. And when I use the vertical axis, the cos change to a sine. If I use the horizontal axis, the trig ratio involved is staying the same. It's a cos and then a cos. All right. Now, it is important that you understand the difference between using the vertical axis and the horizontal axis. And I can see that we're almost there, but we need a bit more practice. So what I want to do now is I want to ask you, can you reduce the sine of 270 plus theta using co-ratios or using the vertical axis? And can you reduce the cos of 270 plus theta? And instead of using the vertical axis of 90, I've now shifted it to quadrant number 4. So if you imagine what the 270 plus theta angle looks like, it starts here, it goes to 180, then it goes to 270, and then it goes, that angle over there needs to be theta. Can you reduce the sine of 270 plus theta? Can you reduce that? And I want you to put the answer in the chat. I'll call this A and this B. Who would like to come online and tell me how to do A? Who feels like they've got this? They're like, I know how this thing works. I'm feeling it. What's the process we can use to reduce the sine of 270 plus theta? Okay, so which quadrant is this in? Yeah, let's go to Annie. Annie, what would you do first? Can you hear me, Annie? We seem to have a bit of an audio issue there, but Annie, if you can hear me, you can come on at any time. I'll do the first one. In quadrant 4, so 270 plus theta is in quadrant 4, and if I'm using the cast diagram, only cos is positive in quadrant 4, sine is negative, and so it will be negative. Okay. Let's go to Leander. Leander, I think your hand is up. I think I'll try and unmute you here. What do you think comes next?
Sir, since sine is negative in the fourth quadrant, and
Yes.
we know that the co-function of sine is cos, so the answer would be negative cos theta.
Perfect. And what about B? Could you give me the answer for B?
Yes, sir. So for B, since cos is in the fourth quadrant, it's going to be positive, and the co-function for cos is sine, so the answer will be positive sine theta.
Absolutely perfect. Absolutely perfect. Thank you so much.
Well,
All right. That was great from the class there. Now, we need to do one more and then we will move, or two more, and then we'll move on from this. So let's say I give you the sine of 300. I want you to reduce the sine of 300 using co-ratios. So I want you to reduce the sine of 300 using co-ratios, and I want you to also reduce the cos of 300 using co-ratios. Or another way of saying it is using the nearest vertical axis. What would you get for that? Let's go to Boma. Boma, what do you think we would do for this one?
Hello, sir.
Hey.
No, I'm not answering the question. I have my own question.
Okay, go ahead. Cool.
So, sir, if you like the sine 270 plus theta thing,
Yeah.
is it still fine if you, because our teacher taught us to like do it like minus sine theta. Is it the same thing?
Okay. So it depends on what, the first thing you ask yourself is what is the angle that you're dealing with? No matter what method your teacher is teaching you, you ask yourself, what quadrant are you in? So in 300, what quadrant would that be in?
Quadrant 4.
4. Okay. Is sine going to be positive or negative in that quadrant?
Negative.
Okay, perfect. So we know that bit. Now we have a choice. If we were using the horizontal axis, we would be talking about 360, but we can't use co-ratios. So in that case, and this question asks us to use co-ratios. So what is the nearest vertical axis to 300?
Cos 60.
So cos 60 would be using the horizontal. So don't you think the nearest vertical axis to 300 would be 270? Are you following me? So I'm showing you a particular method. So in this case, 270 is the closest vertical axis to 300. How far away is 300 from 270?
So you're losing me now, okay?
Okay. So I think what's happening is that, Boma, that you're thinking about using the horizontal axis, and there's nothing wrong with doing that, okay? If you use the horizontal axis and you use sine of 300, what I think you're saying is then you would get minus sine 60, okay? Is that what you're asking, Boma? Is that okay?
Yes.
It's
Yes,
absolutely perfect, absolutely perfect. If you are using normal reduction formula and the horizontal axis, but in this question, we are learning a new skill where we use something called a co-ratio. And instead of using the nearest horizontal axis, we're using the nearest vertical axis. And when you use the nearest vertical axis, it changes from a sine to a cos. So in this case, it's going to become minus cos 30. And you can check on your calculator. In fact, everyone, I want you to check that minus cos 30 is exactly the same value as minus sine 60. And give me a thumbs up if that works. Okay. So today, what's happening there is, Boma, is that I'm teaching you a technique today, which is called a co-ratio reduction, or using the vertical axis. In the previous 2 lessons, we really heavily worked around the horizontal, but I'm going to do one more for you. So the cos of 300 is in quadrant 4. So it's going to be positive. And if I'm asking myself, how far away is it from the nearest vertical axis, I could rewrite it like this, 27 plus 30, which shows me how far away it is, or I can just see it's 30 away. And then in the next step, because I'm going to reduce it using the nearest vertical, I have to change it now to the opposite, or to the co-ratio, and it becomes plus sine 30. Now, in your calculators, again, I know I'm forcing you to check a lot, but check yourself. Is the cos of 300, okay, the same as plus sine 30? If it is the same, give me a thumbs up. If it's different, give me a thumbs down. We need to test the teacher here. We need to make sure I'm telling you the truth, the whole truth, and nothing but the truth. Okay. So what we've managed to do is we've managed to reduce the cos of 300 from a big angle to a small angle. But not only that, we've learned a way to change a cos into a sine, which is fantastic. It gives us options. Now, what we were saying earlier is if we had reduced the cos of 300 off the nearest horizontal axis, it would have been plus cos 60. But that would have been using the horizontal axis, not the vertical axis. Okay, but the good news is the sine of 30 is exactly the same as the cos of 60. All right. I think now, for those students who feel unsure, I would really recommend, we've done about 2.5 hours now on the reduction formula, the horizontal and the vertical, the last half an hour. I'd really recommend to go back, and then in the weekly quiz, there'll also be some more practices on that. But let's just do a last vote. If you're feeling like you understand the reduction formula, thumbs up. If you're feeling quite confused by the reduction formula, thumbs down. And then it's time for a quick little break. And you can be honest. You won't hurt my feelings, I promise. We just want to get a feel for where the group is. Okay, awesome. Well, for those who are still unsure, don't worry. All I would say is that you go back and watch the videos, you do the quizzes, and slowly but surely you will get there. Okay. All right. Now, we've been working for just over half an hour. It's time for a break for our brains. So what I want is I want everybody to get onto their feet. We're going to take a brief brain break. So like this happy chappy over here, I want you to stand up with me, and I want you to turn on your camera.
Please turn on your cameras, guys. Let's see your lovely faces.
Yeah. Okay, now what we're going to do is we've been sitting down for half an hour. Our brains are feeling a bit stressed, I'm sure. And so we need to relax them. So let's just take a couple of deep breaths, like, and then breathe out. And one more. Okay. Then let us do a stretch where we start by just turning our bodies gently. And then as we loosen up a bit more, we can start turning our bodies almost the whole way around, like 180 degrees around. And as you feel more relaxed, you should start to feel your body twist a little bit further naturally. Okay, then shake out your arms, and let's do some circle rotations with our arms. So arms out in small little circles. You should feel your shoulder blades getting a little bit of a stretch, and then slightly bigger circles. And then eventually you can do nice big circles. Okay. Oh, and then just stretch out your shoulders a bit. And then let's roll our shoulders back. So roll them back gently, and then roll them forward gently. Okay, and then shake out your arms. And now we need a high intensity exercise just to get our heart rates up. And what shall we do today? Should we do, let's do knee touches. So basically like this, except that we're jumping. So 1, 2, and like that. Okay, let's do 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay.
Nicely done, guys.
I always feel a little bit silly doing this, and then my brain kind of goes, but I like it. And then it's like there's something about our brains just kind of, yeah. Okay. Yeah. So this is the brain break question for today. I want you to try and make 24 using these 4 numbers. So you have to use each number once, and you're only allowed to use plus, minus, times, and divide. Can you make 24? Can you make 24? Okay. So using 5, 1, 8, and 8, how can we get to 24? Who's got some ideas? I'll give you a hint. If you go 5 minus 1, that gives you 4. So you've used 2 numbers already. How do you use 8 and 8 to get to the number 24 using just plus, minus, times, and divide? Aha. Nati and Boma and Aura seem to have got it. So the suggestion from the chat that I'm seeing, and Chuma has said the same thing, I think you guys have got this. Let's test it out. 4 times 8 is 32. So you've used up one of the 8s, but you've got another 8 to use. And then you go 32 minus 8, and you get 24. Yes. Perfect. And I see Luyanda put the whole answer here. So you go 5 minus 1 in a bracket, which gives you 4. Then you go 4 times 8 is the 32. And then you go minus 8 to get your final answer of 24. And so this game is called Maths 24. And it's a great way to just keep your mental timetables and addition, subtraction working well. Okay. Well done, everyone. That was great. Let's get back to our lesson. So what I'm going to do is I'm not going to move on quite yet. I just want to give a little bit of practice. So what I'm going to do is I'm going to say to you, here is the sine of 240. So this is a trig expression, and it's an angle that's greater than 90. And we are going to reduce this using the horizontal axis, and we're also going to reduce it using the vertical axis. Now, the horizontal axis is normally just called the reduction formula, and reducing it off the vertical is also a reduction formula, but it's called using co-ratios. if we use the nearest horizontal, it would make sense to think of 240 as 180 plus 60. If we use co-ratios, it would make sense to think of the sign of 270 minus 30. Give me a thumbs up if you understand why I've written them like this, where the 180 plus 60 is used for the horizontal axis, and for the vertical axis, I've used 270 minus 30. Give me a thumbs up if you understand how I wrote that and why I wrote it like that. Okay, so you may ask yourself, well, why do I even need to be able to do it in two ways? Well, it's because of the way that we ask these questions, exams, and tests. So for the next step, I want you to write down, what do you think the answer for A is going to be, and what do you think the answer for B is going to be, where A is using the horizontal axis and B is using the vertical axis. Oh, you also could, who's saying add 30? Why not add 30? So the reason, Masemola, you would say not add 30 is you want to use the nearest horizontal axis for the first one. And what's the nearest horizontal axis to 240? It's going to be 180. And for the second one, the nearest vertical axis is 270. And so that's why I'm doing it like that. So I'm using those as reference points because I know the rule. So what's that going to be? So for the very first one, in fact, for both of these, I seem to be in quadrant number 3. Quadrant 3 is CAST. Okay. Now, if I use the horizontal axis, the trig ratio is going to stay the same. It's going to be negative, and then it's going to be sine 60 for this one. For co-ratios, it's still going to be negative, but it's going to be cos 30. Now, I know that's going to catch quite a few of you because I'm focusing now on the two different ways, the horizontal and the vertical axis. But notice how the process is slightly different. You should get minus sine 60 if you were using the horizontal, and you get minus cos 30 if you use the vertical. Let's do another one. We'll just keep practicing. Now remember, the left-hand side, I want you to use the horizontal axis. On the right-hand side, I want you to use the vertical axis. So if I said to you, what is the sine of 210 being reduced from the nearest horizontal axis, and what is the sine of 210 being reduced off the nearest vertical axis? So the one here is horizontal, or the proper reduction formula. Here it's off the vertical axis. See if you can give me answers for that. I'll call that C and D. Absolutely, Talisa, I will. Keep those answers coming in the chat. So I definitely get minus sine 30 for the sine of 210 using the horizontal. Whereas for the vertical, I know it's still in quadrant 3, so it's negative, but instead of writing sine, I now write cos, and I get minus cos 60. Okay. It's looking very good, everyone. It's looking very good indeed. Okay, let's do another one. We'll rather focus on this, and then the next lesson I'll go do trig equations. So let's do, what is the sine of 340 reduced using the nearest horizontal, and what is the sine of 340 reduced using the nearest vertical axis? See if you can do these two. We'll call this E and F. Nicely done, nicely done. I like what I'm seeing out there. I like it. Mm-hmm. Okay, I see Annie, Tato, Manolo all think that it's minus because it's in quadrant 4. And because we're using the horizontal axis, it stays the same trig ratio, and we get minus sine 20. Who would like to come online and tell me how to do F? I'm curious to know if anybody feels confident enough to reduce F off the vertical axis. Anybody be willing to share? Luyanda, let's go to you. How would you approach this one?
So for F, I would say sine 270
Okay. Yeah.
plus 70 degrees.
Perfect. Okay, that's step 1. So we know how far away it is. What's step 2?
And step 2 would be since sine is a coefficient of cos, so you'd say cos 70.
Okay. Okay, now, but what about the plus or minus step? Would you give it plus? So I agree that it's cos.
It's positive because it's in the 4th quadrant.
Aha, I almost agree with you, but here's the thing. Sine in the 4th quadrant isn't actually positive. It's going to be negative.
Yes.
Yeah. Would you agree with me? So I know cos is, but it's okay. Perfect. Love it though. Absolutely love it. Thank you so much, Landa. That was fantastic. So watch out there with F, because it's so tempting when you think the plus or minus comes from the original trig ratio. So when you started this question, sine 340, sine is going to be negative in the 4th quadrant. So something that is negative can't not be negative anymore at the end. So the negative comes from the original. Because we're using the nearest vertical axis, which is 270, I have to switch from a sine to a cos, and I get a 70, but the minus sign comes from the original. Okay. Should we do one more, or do you guys feel like you've got it? Tell me in the chat. One more, or do you feel like you've got this? One more. Okay, E, F, G, H, A, B, C, D, E, F, G, H. Okay, so yeah.
So I think we have a question from Masimula.
Okay, I'll go to Massimola right now. I just want to write this down. So can you reduce this angle of the nearest horizontal and reduce this angle of the nearest vertical? I know I'm being a bit sneaky, but you guys have done so well. I was like, I'm going to bring my A game. Okay, whose question is, let's go to Massimola. Massimola, what can I do for you? Can you hear me, Massimola?
Yeah.
Awesome. What's your question?
Yeah, that was my question. So if the angle is greater than 360, but then I see we got the question.
Aha. Okay. So you were
yeah,
on
I
the
got
same,
it.
we're on
Yes,
the
sir.
same page.
Yes, sir.
Awesome.
Okay.
How would you do it now that I've got you? What's your first step for sine of 390? Okay, I lost you there. Sorry. Okay, I'll give you a bit more time. So how would I visualize 390? Nkate. Let's go to you. Nkate, what do you think we would do from here? Can you hear me? Oh, sorry, I think me and Level clicked at the same time. We're too quick. Yes,
Good afternoon, sir. I mean, evening.
How's it going?
I'm good. How are you, sir?
Very good, very good.
Yes. So the answer for G is negative sine 30.
Okay,
And then
I totally agree with the sine 30, but the negative I disagree, because what quadrant is sine 390 in?
it's quadrant. Is it 2 or 3?
No, it's quadrant 1 because it goes the whole way
1.
around and then it comes
Oh.
into quadrant 1. So it's plus sine 30. But
Okay.
perfect. Now, what about the second one? This is off the nearest. What's going to be the nearest vertical axis? It's a bit tricky.
Yeah, it is. Let me find it out, sir. I didn't.
Yeah, no, it's fine.
No,
That's a hard one. Okay, let me pass it on. Does anybody have an idea? What would the nearest vertical axis to 390 be? Let's go to, anybody have an idea? So if I was looking at vertical axes, there's 90 and 270, but that's not very helpful. Let's go to Leander. Leander, what's the nearest vertical axis? I'm wondering if we are. Oh, I've lost you. Ortega Batso, maybe we can go to you.
Sir, I'm actually not sure, but then I reduced sine 390. I said sine 270 plus 120. Then I reduced 120. I said 180 minus 60. Yeah. Then I used the co-function of sine and said cos 60 because 270 180 minus is on the second quadrant and sine is positive on the second quadrant. So I got positive cos 60.
Okay, so I think we're the same. So let me show you how I would do it. I would just say, and you can do it like that, but 390 would just be basically, if you add 360 to 90, you get 450. And so what I was thinking, and there's a couple of ways to do it, but if that's 360 and this is 390, I was just thinking we could go 450 minus 60 as the nearest kind of thing, but you don't have to do it like that. And then we could say, well, if that is a vertical axis, this would just be, it's in quadrant number 1. So it's just going to be the cos of 60. So did you get the cos of 60? I think that's what everyone else got. So I would just use the same as me. Okay, fantastic. And I see in the chat, everyone was saying the cos of 60 for that one there. Okay, we'll carry on in the next lesson, but you've done really well. I think that was really worthwhile spending extra time on this, and this last one was properly tough. So Lebo, if I could just ask you to put the feedback link out to the students, and yeah, if you didn't see the last two lessons give you a good feel for it, and today was like we mixed it up. And the next lesson we will start with trig equations.